Okay guys, tonight we're going to look at characteristics of quadratic graphs, and again this should be a review from last year. We're going to talk about the vertex, the Y-intercept, the X-intercepts, which are also called the zeros, and or the solutions, or so X-intercepts, solutions, or zero. So we're going to just review some vocabulary from last year, and then we are going to talk about how to find the vertex without graphing. So let's go ahead and get started. Okay, so we have two trinomials here, x squared minus 13x plus 42 and x squared plus 2x minus 24. So if you recall from last year, hopefully you do, this is saying when y equals 0, I want to know what x is equal to. So I'll get an ordered pair with x comma 0. This is going to give me the x-intercept. We call those also the zeros or the solutions. So when we factor this, x squared minus 13x plus 42, the factor pairs of 42 that give me a negative 13 are x minus 7 and x minus 6. So if we were to graph this on the calculator, we need to find where would this parabola hit the x-axis. So that means if y is 0, either x minus 7 has to equal 0 or x minus 6 has to equal 0. So if x minus 7 equals 0, that means x is equal to positive 7, so that's one x-intercept, it's 7, 0. If x minus 6 equals 0, then x has to equal a positive 6, so the other x-intercept is at 6, 0. So if we were to graph that, our parabola would cross the x-axis at 7, 0 and at 6, 0. So let's go ahead and factor x squared plus 2x minus 24. So again, when y is equal to 0, I want to know what x equals, and that is going to tell us the x-intercepts. So another name for the zeros are the solutions or the x-intercepts. So I need factor pairs of negative 24 that add up to 2, and that would be x plus 6 and x minus 4. So either x plus 6 has to equal 0, and that gives us negative 6, so negative 6, 0 is one solution, or one x-intercept, or x minus 4 has to equal 0. And so if x minus 4 equals 0, then x equals 4, so our other x-intercept is at 4, 0. So when we talk about our zeros, our solutions, our x-intercepts, this is what we're finding right here. So if this were the graph of x squared plus 2x minus 24, our x-intercepts would be at negative 6 and positive 4. But clearly this is not the graph, because our x-intercepts here are at negative 1 and positive 3, and our y-intercept is down here at negative 3. So let's go over some vocabulary real quick. What is a quadratic function? A quadratic function is a second degree polynomial. And that means our highest degree is x squared. The parabola is the shape of the quadratic graph. And we can have an upward facing or a downward facing parabola. If you remember, the axis of symmetry is the vertical line that passes through the vertex and it splits the parabola in half. Into two identical halves. So it's basically a line of symmetry. In this case, it passes through the vertex. The vertex is the highest or the lowest point of a parabola. It is either the highest if our parabola goes this way, or the lowest if our parabola opens this way on the parabola. Okay, so let's go back over to this diagram again. Over here, so here is our vertex, and we're going to use for our vertex the variables h and k, and you'll see why when we do our next set of notes. So here's our vertex. The parabola opens up when the coefficient of a is positive, and it will open downward when the coefficient of a is negative, because that gives us a reflection over the x-axis. Our x-intercept is where it crosses the x-axis, and our y-intercept is our constant, and that is where it crosses the y-axis. Okay, so for these two examples, we are going to identify the vertex of each graph and tell whether it's a minimum or a maximum. So clearly, this parabola opens upward, so this is a minimum because it's the lowest point. And the minimum, in this case, here is our vertex. Our x is at about 1/2, and our y value is at -2. Our axis of symmetry, we talked about earlier, would be at x equals 1/2. So our axis of symmetry would be right down, it would split this parabola into two parts. The second graph, okay, here is our vertex, and our vertex is at 1, 1. It's the highest point, so it is a maximum. And those are the only two types of parabolas we'll see. We won't see it facing open to the left or right because then it is not a function. So in the next two questions, we want to identify the y-intercept of each quadratic function. And that's the easy part. The y-intercept is the constant. So the y-intercept, in this case, remember, this is a, b, and c. C equals 9. In question 2, again, the y-intercept is the constant. So the constant, or c, is equal to -5. So that's where it crosses the y-axis. Okay, so finding extrema using zeros. So we are going to use the solutions, the x-intercepts, or the zeros of this equation, x squared minus 2x minus 35, to find the vertex. That's what we mean by finding extrema. So first we're going to factor this equation to find the zeros. The leading coefficient is 1, so I just need factor pairs of -35 that add up to -2, and that's going to give me x minus 7 and x plus 5 equals 0. So either x minus 7 equals 0, and that'll give us x equals 7. So there's 1 0 at x equals 7. Or x plus 5 equals 0. Keep in mind we're trying to find the x-intercepts. The zeros are the solutions. So if x plus 5 equals 0, that means x equals -5. So our two zeros are at 7 and -5. We want to find the x value of the vertex. So if you remember on our parabola, that axis of symmetry cut our parabola into two parts. So if this is an x-intercept and this is an x-intercept, the midpoint or the middle or the axis of symmetry, that x value is halfway between both of those x-intercepts. It's kind of like using the distance formula. So if we average the zeros, if we do 7 plus negative 5 divided by 2, that's going to give us the halfway point between 7 and negative 5. And that halfway point is at positive 1. So positive 1 for our vertex is the x value of our vertex. And once we have the x value of the vertex, we can find the y value. So we know that the x value of our vertex is at 1, and now we're trying to figure out what y is. So to find the y value of the vertex, we use the equation and we sub in 1 for x. So we have x squared minus 2x minus 35 equals y, or 0. So 1 squared minus 2 times 1 minus 35 equals y. And what we end up with is y equals negative 36. So our vertex, or our extrema, our maximum or our minimum, in this case it's going to be a minimum, is at 1, negative 36. So one more method for finding the vertex of the parabola without graphing. So another method for finding the vertex is to use the formula x equals negative b over 2a. And this is going to give us the axis of symmetry. This is going to give us the axis of symmetry, which is the x value of the vertex. So if we look at our function right here, 2x squared plus 15x plus 7, we know it's going to be a minimum because the 2 is positive. And so we're going to identify our coefficient, or all our variables, or our a, b, and c. So this is standard form. So a is the coefficient of x squared, b is the coefficient of x, and c is our constant, and that is 7. It's the number that's by itself. So we're going to use the formula x equals negative b over 2a to find the x value of the vertex, or the axis of symmetry. So I'm going to take out b and I'm going to plug in 15. I'm going to take out a and I'm going to plug in 2, and we really don't need that for the axis of symmetry. And we get x equals 15, negative 15 over 4. If you want to write it as a decimal, it's negative 3.75. So if we are looking for the x value of our vertex, we found it, and it's not pretty, but that's okay. So our vertex, our x value is negative 15 over 4. Now we need to find the y value, and to do that, do what we did above. We're just going to sub it into the equation. So our equation is y equals, or f of x equals 2x squared plus 15x plus 7. I'm going to take out x, and I'm going to plug in negative 15 over 4 squared plus 15 times negative 15 over 4 plus 7. And when that whole hot mess gets worked out, we end up with negative 21 and 1/8. Or you could write it as negative 21 and 125 thousandths. So the the y value of our vertex is negative 21 and 1/8. So those are just two different methods for finding the extrema, or in other words, for finding the vertex, the maximum or the minimum. Okay, now it's your turn. Multiple choice question number 1. Identify the vertex of y equals negative 2x squared minus 12x minus 16. And we are looking for a maximum because this is a downward facing parabola. And number 2, identify the y-intercept of this equation. So what you want to do is you want to solve for y. So you want to get this negative 8 over here, because what you'll end up with is 0 equals whatever. And so we're trying to find the y-intercept. Please make sure you put your answers in on the Google form. Thanks, and have a good night.